So with his speech entitled To Infinity and Beyond, please welcome James.
Madam Toastmaster, fellow Toastmasters, and very welcome guests. To infinity and beyond! Those, of course, were the immortal words of none other than our friend Buzz Lightyear, Space Ranger in the Toy Story films. But is it actually possible to go beyond infinity? Well, tonight I'd like to explore that concept with you and do that through the means of some simple examples. But first of all, infinity itself. This is the symbol for infinity, the endless ring. And what is infinity? Well, infinity is an abstract concept which is all about something that has no limit. And it comes from the Latin infinitas, meaning unboundedness. But rather than start with infinity, I want to go to the opposite of infinity, and that's what's known as infinitesimal, which is something that's so small, it's virtually indistinguishable from zero. And for that, I will need the help of a horse. This is something known as Zeno's paradox. The horse is starting at point A and walking towards point B. Let's call the fence in the background point B. In the first time period, the horse walks half the way to the fence. The next time period, it walks half the remaining distance. And in the next time period, half the remaining distance again. Let's look at this in terms of numbers. After one time period, the horse has gone halfway to the fence, still has half the way left to go. After two time periods, the horse has gone half the way, and then a further quarter of the way. He's gone 3/4 of the way. He has a quarter left to go. And after 3 time periods, he's gone a half, and then a quarter, and then an eighth. The horse has gone 7/8 of the way to the fence. It still has 1/8 of the distance remaining. So if we look at the distances remaining at each step, 1, a half, a quarter, an eighth, I'm sure you can see a pattern. And that pattern continues. 1/16, 1/32, 1/64, and so on. Each time, the distance to the fence halves, but it never goes negative, and it never actually hits 0. So after a great number of time periods, we can be confident that the horse will be virtually touching that fence, but not quite at it. So that was Zeno's paradox. I'd now like to return to infinity. And it's important to note that infinity is not actually a number. Instead, it's used by mathematicians to try to explain a sequence or function that has no reasonable concept of ending. So the answer is so big that we can't comprehend how big it is. And it therefore has no finite number. And we say that sequence is tending to infinity. And I'd like to look at a mathematical example, if I may. The simple one, although you have to understand mathematics, so I'll explain it in words. This simply means, what does 1 over x become as x gets very big? So, let's start off with x equals 1. We get 1 over 1, that's 1. What if x is 2? We get a half. X is 3, we get a third. X is 4, we get a quarter, and so on. Now, there's a great number of steps in this sequence, but I'm going to skip some. 1 over a million, 1 over 2 million, 1 over 56 billion, 1 over 129 trillion. I'm sure you'll agree that's probably a fairly small number. In fact, you might even consider it to be infinitesimal. And what we're basically saying here is that as x gets bigger and bigger. As x tends to infinity, then 1 over x tends to 0. But as in Zeno's paradox, it doesn't actually hit 0. I'd like to now look at the same sequence, but rather than looking at when x gets big, I'd like to see what happens as x approaches 0. And I'm going to use the answers from the previous sequence to help us out here. So if we put in 1, we get 1 over 1. If I put in a half, we get 1 divided by a half, that's 2. We use a third. 1 divided by a third equals 3. And if we continue through the same numbers that we saw in the initial sequence, then eventually we get to 129 trillion. When we get to this stage, that certainly seems like a big number. But I know that 1 over 129 trillion and 1 is smaller, than 1 over 129 trillion. And therefore, when I put that number in, it will give a bigger answer. 129 trillion and 1 rather than 129 trillion. So therefore, as x gets smaller and smaller, approaching 0, x gets bigger and bigger and bigger, and we therefore say, that 1 over x tends to infinity. I'd like to return to our friend to conclude, Mr. Buzz Lightyear, Space Ranger, and his phrase, to infinity and beyond. Well, what have we learned today? Firstly, to infinity. Well, actually, we can tend to infinity, we can approach infinity, but we can't actually get to infinity because infinity is a lack of a boundary. So therefore, that part of his statement is false. And if you can't get to infinity, then most certainly you can't get beyond infinity, and therefore that part of his famous phrase is also false. That being said, it is a good phrase, I'm sure you'll all agree, and I'm not sure that my equivalent, tending to infinity, and most definitely not beyond, has quite the same ring to it. Madam Toastmaster.
I certainly understood some of those words in there, but not always in the order James presented. That might just be me. Now we have the session of evaluating. Somebody